Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and today we've got part 2 of my series, Lessons Learned in Amateur Astronomy. In this series, what I'm trying to do is I'm trying to go through all of the mistakes that I made when I first got into amateur astronomy so that you don't have to. Now, in our first episode, we talked about the most important piece of equipment to an amateur astronomer, and that's his telescope mount. Today, we're going to actually start our discussion of telescopes, with basically learning a little bit about the parts of a telescope, and then we're going to discuss some of the numbers that they talk about with telescopes, such as aperture, focal length, and f-stop. So let's cue up the music and get going. Now, most of us are very familiar with optics. We all have cameras on our cell phones. Now, another type of optics that we're familiar with is binoculars. A binocular is just basically two telescopes stuck side by side, and you look through one telescope with each eye to see an object in the distance. Now, a word about binoculars. They're an excellent way to learn the skies. These are actual astronomical binoculars. They're very powerful binoculars, but they require a stand because they're very heavy. You can do some good amateur astronomy with nothing more than your naked eye, a cell phone camera, and a pair of field glasses. But the main thing that I wanted to talk about today was telescopes. Now, we've got two telescopes right here. This is called a refractor telescope. This is a Ritchey-Chrétien telescope. Let's go over some of the parts. Now, just going from the front to the back, we have a lens cap cover right here. Now, in the front, we have an aperture lens. On small telescopes, this is listed as millimeters. This is an 80 millimeter telescope. On larger ones, the aperture or the opening in the front is generally listed as inches. This is an 8-inch telescope. In the back here, we have a 10-inch Schmidt-Cassegrain telescope. Now, this device around the end of the telescope is called the dew shield, and it slides out to give a little bit of an air buffer between the telescope aperture lens and the outside air. This helps combat a problem that we have in spring and fall days. This telescope lens gets cool and water tends to condense on it in the form of dew. In the winter, that actually freezes to ice. Now, with dew, you can kind of wipe it off, but once you get ice on the end of your telescope, your evening is pretty well over. The main body of the telescope is called the optical tube assembly, or the OTA. This has a series of lenses in it in this particular type of telescope. In here, we have some mirrors. These are the telescope rings, and they secure it to what's called the rail. And that's this part right down here, this red part. Now, there are two types of rails. You have a narrow Vixen rail, and then on the back here, you can see a very wide Willis-Mandy rail. This is what attaches to the telescope mount. It slides into a groove and it's locked in. This is a little modification that I have right here. We'll just ignore that for right now. Now, going further back, this apparatus right here is where you attach either a guide scope or a finder scope. Here is a coarse focusing knob. And on the other side, you also have a coarse focusing knob and you have a fine focusing knob. 10 turns of this knob equals 1 turn of that one. And that's used to adjust what's called the draw or the focuser tube. By making that shorter or longer, we bring the image that comes in through the telescope into focus back here at the eyepiece, or sometimes you'll put a camera back here. Now, looking at this Ritchey telescope, the design is a little bit different than our refractor. As you notice, there's no glass or lens here in the front. What happens is light comes in the front of the telescope, it bounces off a primary mirror in the back, it comes up and hits a secondary mirror right here, and then it's reflected through a hole in the primary mirror back to the focusing area. Now, this is a focuser. This is something called a guide scope, and here is the camera on the back of the telescope where the eyepiece would be. Now, normally, without this electronic focuser, we would have a series of knobs and a draw or a focus tube just like the other one. So this is kind of a hybrid between the back end is kind of like a refractor, and the front end is very much like a Schmidt-Cassegrain telescope, which is in the back. And again, we'll go over the design of all these telescopes in our next episode. Well, let's go over some of the terms that you hear talked about with telescopes. The first one is something called aperture size. Now, the aperture size is the size of the opening at the front end of the telescope. This is 80 millimeters. This one over here is 8 inches. And what that has to do with is the amount of light that is allowed to enter the telescope. Now, the way that works is, say this is an 80 millimeter telescope right here. If we double the size to 160 millimeters, we let in 4 times the amount of light. The more light that comes into your telescope, the clearer things are to your eye, and the better pictures that you can take with shorter exposures. Now, another thing that they talk about a lot is the focal length of a telescope. The focal length of a telescope is directly related to the amount of magnification. So the more focal length you have, the more magnification you have. So this telescope is 580 millimeters in focal length. The Ritchey-Chrétien is 1620 millimeters of focal length. So this telescope will magnify objects much more than this telescope will. However, there's a drawback to it. If you have a shorter focal length telescope, you have what's called a wider field of vision. In other words, when you look at the objective in the telescope eyepiece, you'll see an area of space where there are stars. Now, on a short focal length telescope, that area covers an awful lot of space. On a long focal length telescope, you're zeroed in on a very specific spot, and you have a lot of magnification in that spot. Now, another thing that involves focal lengths is the amount of light that comes in. If you take 2 telescopes that have the same aperture size, but one has a longer focal length than the other, the image that appears in the more magnified, longer focal length will be dimmer than the image that appears in the wide field telescope. Now, likewise, if you have 2 telescopes that have the same focal length, if you have one that has a larger aperture than the other, it will let in more light and the image will be brighter. A smaller aperture will give you a darker image. Now, the final factor to consider is something called the field stop, or the f-stop of the telescope. The f-stop of a telescope has to do with how fast the telescope can actually take an image. So if you need a certain amount of light reaching your camera sensor in order to capture an image, you'll have to take a much longer exposure with this telescope compared to an f2 telescope. And the way you determine an f number for a telescope is you take the focal length and you divide it by the aperture size. Now, so for example, this little refractor has got a focal length of 580 millimeters, and it's got an aperture size of 80 millimeters. So we take 580 and we divide it by 80, and we come up with an f7.25. The Ritchey-Chrétien telescope is 8 inches in aperture, and it has an f number of 8. So multiplying the aperture 8 inches by the f number 8, you get the total focal length of the telescope, which will be 64 inches, or 1620 millimeters. Now, to give you an idea of how this comes into play, look at this beast. This is my 11-inch RASA telescope. It is an 11-inch aperture telescope, but its focal length is 620 millimeters. It's only 40 millimeters longer than this one. And while this is an f7.2, the RASA is an f2.2. Now, to give you a practical demonstration of what that does, if you take a 1-minute image with a RASA, to get the same amount of light to the camera, you have to take a 15-minute image with this Ritchey-Chrétien. And one thing that I think most people know is that if you use a high focal length, like f11, that means you've got a very tiny aperture in your camera. You have to expose it a little bit longer, but your depth of focus is great. Your foreground will be in focus, your subject will be in focus, and the background will be in focus. However, if the light's a little bit lower, or you want to photograph something a little faster, or you want to isolate your subject, what you do, you can drop that down to an f-stop of 2.8, and then when you focus on your subject will be in focus, but the foreground will be blurry, and the background will be blurry. You have a very narrow depth of focus right where your subject is. Now, while focus is always important with a telescope, it's absolutely critical with a RASA. You have to have a very good focus in order to get your subject clear with a RASA. With these slower telescopes, f8 or f10, you can be slightly off on your focus and still have the object you're looking at in decent focus. Today is a very short episode. I just kind of wanted to go over some of the parts of telescopes and talk about some of the terms that we use with telescopes. In our next episode, we're going to talk about the different types of telescopes and why a RASA or a Schmidt-Cassegrain, a reflector or a refractor may be the choice of what you want to do. So that's it for today. This is Bob the Science Guy signing out from Shamrock Banks Observatory in northern Michigan. Thank you very much for stopping by and visiting with me today. In next episode, we'll talk about the different types of telescopes. You guys take care and clear skies to you.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob, this side.